Hello there, welcome back to Technology Innovation Hub. So let's continue our explanation from the previous session about deprecating Docker as a container runtime on Kubernetes. Let me share the screen. So it's going to be the session 2 on that architectural analysis we were doing. Session 2, let's start that one. And okay, let me pull it full screen. Okay, what about Kubernetes and container runtime? So in the previous session, we were talking about evolution of container runtime related to Docker. Now we come to Kubernetes related container runtime. Now the very first thing is, let's take a look at this. We are going to explain deprecating approach with Docker because we have different approaches now. What is deprecating? That we need to understand. And the new approach also, and the current approach. So let's take a look at it. And the very first thing is a container runtime. So as for Kubernetes, a container runtime is a software that can execute the containers that make up Kubernetes pod. That's okay, because as far as Kubernetes is concerned, it's a container orchestration platform. So it's going to be specific. Earlier we talk about generic container runtime. And when it's come to Kubernetes, Kubernetes is a platform which is going to orchestrate containers. So as far as the end user demand is going to keep the containers up and running. So container up and running means a pod should start because containers are running within the pod. So that's what it says. A container runtime is a software that executes the containers that make up a Kubernetes pod. Understood? Minimum requirement for a pod to survive is a one container. It's clear. And you can see this one. This is a reference from this. I have given the reference right away. So this is from their so from their documents. You can see containers. What is a container runtime? A container runtime is a software that is responsible for running containers. Kubernetes supports several container runtimes. Yeah, Docker, we know this is going to be deprecated, and container D, CRIO, and the implementation of the container runtime interface. So let's talk about this one. Okay, let's continue. And deprecating approach. So let's take a look at the deprecating approach first. What is going to get depreciated? So let's deprecate it. Let's see what is going to get taken away first. Now this is what they are telling. Again, a reference document from Kubernetes itself. Check whether Docker shim deprecation affects you. So they talk about a word called Docker shim. What is Docker shim? That is another thing you need to understand. The Docker shim component of the Kubernetes allow to use Docker as a Kubernetes container runtime. Kubernetes built-in Docker shim components was deprecated in release 120. So that's why. So Docker shim is another component. We can say it's a kind of a runtime part, which allowed Docker images to be deployed in Kubernetes. So that's what it says. Docker shim component of Kubernetes allows the use Docker as Kubernetes container runtime. I mean, Docker as a runtime has been facilitated by Docker shim. So that's a problem, because now it's an extra burden for Kubernetes to continue this one, maintaining it separately just because of to facilitate Docker images. I mean, Docker runtime. Just to facilitate Docker as a runtime in Kubernetes, they had to maintain another additional component. So actually, that's one of the main reasons why they want to discontinue this one and initiate it on V1, V2.0. Deprecation has been initiated. Right now, if you go down, you can see dependency on Docker explained. So this is further explained in this way. A container runtime, now we know what is a container runtime, and we have understood under the architecture, kubelet is the one which is initiating the container runtime and trying to spin up the container, and the pod will come up. So that initially the pod will come up, then within the pod, the container will get initiated. So that you all know because we have gone through the architecture. But the latter part, in the earliest releases, Kubernetes offered compatibility with one container runtime. What is that? Docker. So initially, Kubernetes is also heavily dependent on Docker. Very first, 2012, 14. So initially, so it heavily dependent on Docker. That was the only runtime they gave. Later, Kubernetes project history cluster operators wanted to add up additional containers. The CRI was designed to allow kind of flexibility. So what happened next? Container runtime interface. They developed a common interface called container runtime interface. So then what happened? And the kubelet began supporting CRI. However, because Docker existed before CRI implementation was invented, the Kubernetes project created to adapt component Docker scheme. So that's the problem. Because this particular CRI, the CRI is a separate initiative. It's an interface which is going to support several other runtime technologies, I can say. It supported containerd, supported CRI, and it was linked with open container initiative. Whereas this Docker runtime was there prior to building CRI, it is very understood. But now there was a little bit of miscompatibility between CRI and Docker, because Docker is totally with Docker organization. Now here Kubernetes is coming up with something called CRI. So to bridge the gap, what Kubernetes did, they introduced a component called Docker scheme. So it's a temporary thing. Anyway, from the beginning, if you look at the GitHub repositories, their proposals, they are directly telling it's a temporary thing. So now they are taking it away. That's what's happening. And you can see CRI specification, no, okay. And the Kubernetes project created an adapter component. So that's what, to adapt Docker runtime, but they did with CRI. Initially, Docker runtime was there, but they introduced something called CRI now to support different runtimes. Otherwise, it's also heavy dependent only with Docker. No? So to take it away, they introduced CRI. But now CRI is having a miscompatibility with Docker. To support that, they added another adapter called Docker scheme. The Docker scheme adapter allows kubelet to interact with Docker as if Docker were CRI compatible runtime. As if Docker were a CRI. Yeah, because now CRI is not compatible with Docker. That's what on the other hand they are telling. To make it compatible, they introduce Docker scheme, so it works as compatible. That's what they are telling. Now this is the pictorial explanation that they are doing to take it away. I mean, what they have done, how you can see it. Let's go through it as well. I think I have explained in the slide, but doesn't matter. You can see this is the initial one, Docker. This is with Docker runtime. So kubelet is there, container runtime interface is there. To occupy Docker runtime, we need to have Docker scheme and the Docker runtime also there. Now, so together with this one, it will make a compatible environment. And Docker anyway had containerd. So they are anyway having containerd within it. So after that, containers are up and running with this runtime. Because this is the very first original initiative with Kubernetes. Then they had Docker as well as the containers, because Docker has containerd, you know. So then containers were running using containerd with Docker runtime. But with containerd, now as a replacement, if you want to introduce containerd, now what's going to happen? This is the replacement for Docker actually. Kubelet is there, container runtime interface anyway is there. And now the scheme part is taken away. Why the scheme part is taken away? Because this Docker runtime is deprecating. So as per the announcement, this particular Docker runtime is deprecating. So once it's getting deprecated, the replacement component is what? CRI container runtime container. So this is the replacement component. And then containerd will manage the container. So that is what part 2 is. Fine. So let's get back to our presentation here. I think the same thing is explained in different ways. So now let's go through it. You can see we have kubelet. Kubelet is the one which is initiating pods, and then only the containers will be scheduled. So kubelet is on the worker node, we know that, and container runtime interface is there, which provides the common interface to execute the runtimes, maybe containerd, maybe CRI, or maybe gvisor, maybe Docker. Now we had by this one, this is the deprecating approach. So deprecating means this is the Docker approach. Now we have Docker scheme because CRI is not compatible with Docker runtime. We have Docker scheme intermediate to facilitate to bridge the gap. We have Docker scheme, and after that we have Docker, and Docker is using containerd to execute the containers, and the containers are coming now. So that is the old approach. This is what they are suggesting to deprecate. This is what has been working up to 120. So after 120, they want to deprecate this approach. They want to discontinue this approach. So then what is the suggested approach? The suggested approach is this, the new approach. Suggested approach is we have kubelet, no change. We have CRI, container runtime interface. Will Docker stream be there? No, there is no Docker stream. We have CRI container D. That's what. So this part is totally taken away because we don't have Docker anymore. So Docker dependency taken away means no need to have Docker stream. So then incoming we have CRI. We have CRI and container D will act as the runtime because CRI is compatible with container runtime interface is compatible with container D. And then what's going to happen? Container D will take care of the containers up and running. You can see the containers up and running. So now the new approach, but they are telling now the latest update is telling 124. Now earlier update I mentioned in the when I do the practical, they are planning to deprecate this one later 221 with 1.22. But as for the latest update, they are telling they are going to deprecate in 1.24. 1.24. So we have future versions coming to be arrived. Okay, so this is what is the deprecated approach. We don't have Docker anymore. We have container D with CRI. This is not all. We have the current approach because they have done an enhancement for this. What is the current approach? So the third one, the current approach. The current approach is this. You can see kubelet is there, CRI is there as it is. Now there is a change done here. CRI and container, you can see container D, the plugin. CRI is now act as a plugin within container D. Earlier we have CRI separately actually. CRI separately. CRI is there separately, but now it is just a plugin within container D. So that's the latest change. That is what they are telling as of current. Of course, we can take away this CRI. This box, if you want, we can take away this black CRI part. It's fine. So then what is again is further shorter. The cycle is further shorter. It's much more performance wise, much higher. Now this fellow right away will open up containers. So that is what this is the latest current approach. Okay. You can see the three approaches. Architectural perspective, the changes are highlighted here. I think you got the picture. But let me just go to this their documents as well. The current approach is explained in their documents as well. So let's go to that one. You can see Kubernetes container integration goes general availability. Kubernetes container integration goes GA. You can see architectural improvement. So this is what I was explaining earlier. Docker was the original approach replaced by container D. That's a part 2. And third one, this is what container D CRI plugin current. So this is what I was just explaining. So now you can see this container D kubelet CRI container. Then we have this one as separated components here, CRI and all. And but now you can see CRI has just become a plugin on container D. So these two components have been merged kind of. That's what happened. CRI plugin with container D. So it works together. I think that is what is explained here. You don't have container D separately anymore. CRI plugin container D works together. So that is the same thing explained here, which is much more powerful. And you can see they are explaining further with the performance and all. For startup latency, it has gone down. The latency has gone down. You can see with container D 1.1. This one, yeah, and again they are talking about CPU usage. Everything is going down. So performance wise, much better. CPU usage goes down. That means higher performance, and likewise memory usage going down. That means higher performance. Likewise. Okay. So that is very important to understand this slide. I think you can, if you have any questions, you can put comments on the channel as well. I can further explain. And so that is the architectural change on Kubernetes side. Fine. Okay. Now the impact. I think we can go that one in the next explanation. So let's try to get it little by little. Just try to get it little by little. So I will do that in the next explanation. If you like the video, you can put a subscribe, and let me meet you soon. Okay, have a great time. Right, bye bye.